Okay, students, if you're watching this video, then obviously you need a little math help on your homework, or a little homework help on your math assignment. Usually I have all this typed up, but it was such a small assignment, I'm just going to write everything down, and it should not take long at all. If this is not the assignment you're looking to do, then you're on the wrong video. This should be pages 390 to 340. Very simply, numbers 9 through 17. 9 through 17. Okay, and so without any hesitation, let's whip through this. You're more than welcome to, of course, you can't speed me up, you can always pause it, so pause it if you need to. Okay, number 9 looks like this. Here's number 9. All right, and I believe if you look in your book, we have a length of 15 for this side, and we have a length of 14 for this side. And look at this, we have parallel symbols here and parallel symbols here. Now the directions say, determine whether this is a trapezoid, parallelogram, rectangle, rhombus, or square. Well, students, we know that it's not a, I'm going to write this up here, trapezoid, parallelogram, rectangle, RH for rhombus, or square. Well, we know it's not a parallelogram because parallelogram has opposite sides are congruent. So if it's not a parallelogram, it can't be a rectangle, and it can't be a rhombus, and it can't be a square, because a rectangle is always a parallelogram, a rhombus is always a parallelogram, and a square is always a parallelogram. Now, it might not be a trapezoid, it might be nothing. But let's see. The definition of a trapezoid is exactly one set of parallel sides. And you guessed it, that's what we got. Here's a parallel. Oh, that's not what I wanted. Let me go back real quick. You've got this side right here and this side right here. They're parallel. And these sides are not. So you have exactly one set of parallel sides. We have a trapezoid. All right, moving on to number 10. All right, number 10 looks like this. Number 10. All right, kind of like a baseball diamond, and we'll try to draw that decently well. And let's see, what do we got? We've got a mark here, a mark here, a mark here, and a mark here, and a right angle right here. There we go. All right, now, okay. Well, let's see what we have. I mean, I do know what I'm doing. Sorry about the pause. I just don't agree with the answer they have here, and I'll show you why in a second. Trapezoid, parallelogram, rectangle, rhombus, or square. Now, maybe they wanted you to pick just one of these that covered everything. I don't know. But first of all, anytime you have a quadrilateral with opposite sides congruent, like this side here is congruent to this side here, and this side here is congruent to this side here, both sets of opposite sides are congruent, you have a parallelogram. That's a theorem that we learned. So I know it's a parallelogram. If it's a parallelogram, it can't be a trapezoid. You can never have a trapezoid and a parallelogram. It's one or the other. Well, rectangle means you got to have 4 right angles. Well, if you have a parallelogram, what do we know about opposite angles? When you have a parallelogram, opposite angles are congruent, so we know that's 90. And you know the consecutive angles are supplementary, so that's got to be 90, because 90 plus 90 is 100 degrees, and then opposite angles are congruent, that's got to be 90. So we got a rectangle, we got a rhombus, and we got a square. All right, so there it is. Moving on to the next one. Number 11. Number 11. And the picture looks like this. And all that they give us is right angle markings there, 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 there. Now let's see, we got trapezoid, parallelogram, rectangle, rhombus, square. All right. Well, I mean, excuse my grammar, it ain't a trapezoid. I mean, obviously, it's not a trapezoid. All right. Well, folks, we learned this. Anytime a quadrilateral has both sets of opposite angles congruent, are these two angles here congruent? Yes, they are. And are these two angles here congruent? Yes, they are. Then you have a parallelogram. So we know for sure we have a parallelogram. Do we have a rectangle? Well, all that you need for a rectangle is 4 right angles. We have that. Now, be careful on the rhombus. For a rhombus and a square, you have to have all 4 sides the same. And they could be, but we don't know for sure. So if you don't know for sure, you cannot state that, okay? So we have a parallelogram and a rectangle. Okay, moving on to number 12. Now they're kind of switching gears. They just want you to simply say yes or no and tell why. And let me show you what I'm talking about. Here's the diagram that we have. And then they have a congruent symbol here. Let me fix that. A congruent symbol here. This thing's really messing up. It's freezing up. There we go. And a congruent symbol here. And then a congruent symbol. Wonder what's wrong with this thing. There we go. And then 2 here. All right. And here's the question they ask. Do you know for sure that this is a rhombus? Well, it sure looks like one, but we can't go by looks, okay? So first of all, are my opposite angles congruent? Are these two congruent? Yes. Are these two congruent? Yes. So I know for sure that I have a parallelogram. I know that for sure. And that's important because that's the first step in deciding whether you have a rhombus. A rhombus has to be a parallelogram. So far so good. Check. But now it has to have 4 congruent sides. Well, it looks like it does, guys. You can't go by looks, okay? And there's no way to know for sure if this side and this side and this side and this side are all congruent. We don't know for sure. So we cannot state for sure that we have a rhombus. So we're going to have to say no, we're not for sure. Okay, number 13. Number 13. Okay, is this a trapezoid? Is this a trapezoid? Well, let's see what we got here. Comes down, over, then a little more of a slant, and then up like that. And we have 60 here. We have 40 degrees here and 140 here. And that's all they give us. Now, look, I went over this before with you guys. Okay, when I say, look, I'm not being grousy, but look, take this side here and extend it. Take this side here and extend it. And then extend this side here. What do you have? You have 2 lines, 1, 2, cut by a transversal. Well, look at the consecutive interior angles. Aren't they supplementary? I know it's hard to see, but it's 140 degrees. So 140 plus 40 is 180. You learned last semester that when 2 lines cut by a transversal have consecutive interior angles right here that are supplementary, then these 2 lines are parallel. You should have learned that last semester, and now you see how math builds. And so we know for sure, let me get rid of all of this, we know for sure that this line here is parallel to this line here. And that's all you need for a trapezoid. All that you need is one, well, not, you have to have exactly, and that's what we have. We have exactly one set of parallel sides. So yes, it's trapezoid. Big yes. Most definitely. Yes. All right, let's take a look at number 14. Number 14. Okay, is this diagram an isosceles trapezoid? Well, let's take the information. Again, don't look at what it looks like. Just look at the information they gave you. Now, yes, it looks like this side is parallel to this side, but you can't go by looks. And even though my drawing doesn't look that good, if you look at the one in the book, it does look like this side is congruent to this side, but you can't go by looks. And so what we have to say is this: is there any way to prove that this line here is parallel to this line here? We have to have that first. In order to have any trapezoid at all, we have to have exactly one set of parallel sides. Well, students, the answer is no. I mean, there's just no way that I can, let me slide this over, there's no way that I can prove that this top side here and this bottom side are parallel. And so the answer is no. You cannot state this is a trapezoid or an isosceles trapezoid. There's just not enough information. You just don't know for sure. All right, we're going to take a look at number 15. Number 15. Do we know for sure that we have a rectangle? Well, let's draw the picture. There we go. And they're saying that all 4 angles are congruent. So let's mark that. that one, and that one right there. Now, let's take this one step at a time. Actually, let's not. Let's just do this real quick. If you have a quadrilateral, what do all four angles have to add up to? Do you remember? 360. Now, if all four angles are equal, then just divide this by 4, and what do you come up with? 90. So you know that all four angles have to be 90 because it says all four angles are congruent. So you know they have to be 90, and look what you have. You have a quadrilateral or a parallelogram quadrilateral with four 90-degree angles. Well, that's the exact definition of a rectangle. Yes, that is definitely a rectangle. All right, number 16. Number 16, it says, do we know for sure that we have a square? Well, let's go like this. Wow, let's not go like that. Let's try that again. All right, and let's put a right angle symbol here. And then a couple of diagonals going across. And I believe they want a right angle marked right here. Now, is it a square? Now, would you please listen to me carefully? I will explain this well. We have a theorem that says if the diagonals... Okay, sorry students, I'm back. I had to take a quick break there for a second. Okay, what I was saying is this. You have diagonals here that are perpendicular. Do you see that? And so right away you might think, yes, we have a rhombus. We have to, but be careful. Please be careful. Look, I know that if you have a rhombus, then the diagonals are perpendicular. But I always use this example with dogs, and I've said it a million times, but look, I can say if I have a German Shepherd, then I have a dog. But I cannot say if I have a dog, then I know for sure I have a German Shepherd. It's the same thing here. If you have a rhombus, then you have perpendicular diagonals. But you cannot state if you have perpendicular diagonals, then you have a rhombus. Let me give a counterexample. Watch this. Let me get another page of it. Please watch this. Would you not agree with me that I'm drawing that line straight up and down and one straight over? There. Would you not agree those two lines are perpendicular? Sure they are. And now I'm going to draw a quadrilateral right around these, like they're the diagonals. There. So I'm drawing a quadrilateral. Do y'all see it? There's my quadrilateral with the diagonals. So here's my four sides. There's one side, there's another side, there's another side, and here's my fourth side. There's my four sides. Are these not diagonals? Yes, they are. Are they not perpendicular? Yes, they are. But is that weird shape a rhombus? No way. And so you cannot state that you have a rhombus. Now, if you can't state that you have a rhombus, you really can't state that you have a square. I mean, how in the world can you even begin to prove that all four sides are congruent? Okay, that's just going to be really, really difficult to do. Okay, and so no, you cannot state for sure that this is a square. Okay, moving on. That was a pretty tough one. Moving on to number 17. Number 17. Do we have for sure a parallelogram? Well, here's the picture you should see in your book, something like this. And they give us congruent symbols here and here and here and here. Well, of course, yes, yes, yes. We learned 5 ways to prove that a quadrilateral is a parallelogram. Here they are real quick. Number 1, if both sets of opposite angles are congruent. Number 2, if both sets of opposite sides are congruent. Number 3, if one angle is supplementary to both of its consecutive angles. Number 4, if both sets of sides are parallel. And number 5, if the diagonals bisect each other. Well, one of those ways I just mentioned is if both sets of opposite sides are congruent. Well, is this side marked congruent to this side? Yes. Is this side here marked congruent to this side here? Yes. So yes, we definitely have a parallelogram. Hope this has been helpful. If it has been, please just send me money. I'm kidding. But hopefully this is helpful to you, and study for your quiz. All right.